So I wanted to go back and look at the 4-4's activity, and I noticed that there was one expression, this 4 plus 4 minus 4 divided by 4. That same expression was used both to represent, to represent 1 and to represent 7. And I want you to stop and think about this for a minute, like actually pause the video and think about how you could get 1 out of this calculation and how you could get 7 out of this calculation. So one way that I could see, and it might not be the only way, if you were to go strictly from left to right, 4 plus 4 is 8, and then we do 8 minus 4 is 4, and then take 4 divided by 4. That would be 1. So that's one way to get 1 out of that expression. That would be working from left to right. And then somebody else actually put in some parentheses and basically did, 4 plus 4, these together, and then did the 4 divided by 4, and then subtracted. So that would have been 8 minus 1, and that would have been 7. So those are two different possible outcomes from this same calculation. And you might pause to think, are there any other outcomes that you might be able to get from this same calculation? I can think of at least one more, but I'm going to leave that up to you. And so one of the things that arises here is the question of, like, which one of these should we mean? Should we mean to move left to right, or is there some other way to describe this order? Or should we mean this order, and how would we describe it? And this really brings into play what should the order of operations be, and that is really about our communication. And I want you to take a moment to notice that this is a communication with some symbols that we are using. We are using these plus, minus, divide symbols, and that's all of this is very abstract notation that we're accustomed to some degree, but it's all about notation. And this is not actually about the math that's happening. It's about the notation that we use to describe the math. And so this question about which operation we should do before which other operation is something about communication. And at least several people in the 4-4's activity did use parentheses, and that's basically another way to communicate. In this operation, it shows I want to group these things together. That 4 plus 4 should be one entity, and we know that 4 plus 4 is 8. This 4 divided by 4 should be one entity, and we know that 4 divided by 4 is 1. So that parentheses communicates that we should group those pieces together to get 8 minus 1. Okay, so anytime that you're writing anything and you want to clarify what operation should be done first, you can always use parentheses to group things together. And then the question is, if I just leave this out here without any grouping, then how are how, like, if I write this, how are you to understand how I mean these operations? And that goes into, now we have developed a convention, which is basically just an agreement among, I would say, almost all of the people who use these symbols, of what order we will do things in if there aren't parentheses or some other grouping mechanisms to indicate what the order is. And that is called the order of operations. And I want to specify that this is a convention. It is not a mathematical truth, it's a convention of notation. The order of operations is, I'm going to put that up here. The order of operations basically says that if you want to specify anything, you should always just use grouping symbols first. Absent grouping symbols, exponents would come before multiplication and division, and other operations. So exponents, by the way, are these little superscripts. So if I say 5 to the third power like that, that means 3 copies of 5 multiplied by themselves. Like that. After exponents, you should do multiplication and division. And after that, the very last thing is addition and subtraction. So some people will remember this order of operations by a popular acronym PEMDAS. And I'm going to write that here, and then I'm going to erase it probably. I have a problem with PEMDAS, and I know that Khan Academy does use PEMDAS. A lot of people use PEMDAS. If you look in the Khan Academy videos, he quickly mentions that multiplication and division are on the same level, and addition and subtraction are on the same level. This is exactly the problem that I have with PEMDAS, is that it looks like multiplication should come before division, and addition should come before subtraction, but that is not the case. In fact, multiplication and division are the same operation, and addition and subtraction are the same operation. And I'll mention that a little bit more after a couple of examples. So, when you say PEMDAS, I've just seen so many students get confused, and going through some sort of calculation, they'll go, "Oh, but I thought that multiplication was supposed to come before division," and so that's not the case. So if you are the type of person who loves acronyms to help you remember things, then I give you this one, which is GEMMA, which is grouping symbols, exponents, multiplication and division, and addition and subtraction. Okay, let's go and see how this works, and I'm also going to show you some caveats of things to be careful of. So here's some things that have a few different operations. The implied operation here after this 2 is multiplication. And of course, the grouping symbols here indicate that 5 plus 8 is supposed to be 1 unit. Okay? So I want you to kind of think about what the notation means too, and just sort of not go and hone in so much on the order of operations as a rule set, but also some of this notation should actually make sense in terms of how it's used. So the parentheses are definitely a grouping symbol that say this piece goes together. So that 5 plus 8 is 13. And so what we have is 2 times 13. And I'm basically writing everything around that 13. That is just that 13 is the first thing I did. Now in this case, we have a subtraction to deal with and we have a multiplication. And the convention is we always do multiplication and division before we do addition and subtraction. So the 2 times 13 is going to take precedence. So I'm going to do 26 there. And I'm going to subtract that from 4, and I'm going to get negative 22. Okay, I know it is very tempting to do the 4 minus 2 first and get basically 2 times 13, which would be 26, but that is not what we're going to do here because the multiplication takes precedence over the subtraction. Okay, let's do another one. So this one has only addition and subtraction. And there are many books that will give you the convention that if you have a big string of only addition and subtraction, since addition and subtraction sit on the same level, you just always go left to right. The problem with this, as we've seen before, I mean, it's not really a problem, except that it is a problem of not being very flexible. So, as we've seen before, though, subtraction can be taken to mean the addition of the opposite. So we could see this as the same as 6 plus 7. Subtracting 2 is the same as adding negative 2. Subtracting 4 is the same as adding negative 4. And then plus 3. And when you have all addition, we found with the commutative property of addition that it doesn't matter what order you add things in, you always get the same answer. So sometimes it might be actually very helpful to add things in some other order than straight left to right. So maybe you might see a 7 plus 3 and see that as like a friendly number that you like, and that is 10. And you might see 6 minus 2 and think, well, that feels good to me, so I'm going to do 6 minus 2 is 4, and then I have plus negative 4 plus 10. I know 4 plus negative 4 is 0, and so we have 10. And I want you to take a moment to notice that if you add this up left to right, 6 plus 7 is 13. 13 minus 2 is 11. 11 minus 4 is 7, and 7 plus 3 is 10. So we're still getting 10, and even if as long as you make sure that the 2 is negative and the 4 is negative, if you do this in any order, you will always get 10. Okay? So this is a little bit of a thing that I want you to be cautious of, is I want you to remember that subtraction is really addition by the opposite of a number, and so you can do addition and subtraction in any order as long as you keep the negatives with the proper terms. So this is a negative 2, this is a negative 4, so I can write this in any way I want. I can write 6 minus 4 plus 7 plus 3 minus 2, and as long as the 4 is negative and the 2 is negative, I can put this in that order. So this could be 2 plus 10 minus 2, which is 2 plus 8, or maybe it's 12 minus 2. Either way, it's 10. Okay? So on that same note, in the topic of this week, we have division, we see, is the same as multiplying by the reciprocal. So here we have a string of multiplication and division. And if you ask yourself which one I should do first, you might notice that you can get two different answers. So if I do 6 divided by 2 first, and then multiply that by 3, that is 3 times 3, which is 9. However, if I do the 2 times 3 first, and then take that divided into 6, that is 6 divided by 6, which is 1. And you might ask yourself, now, which one is it? I've got multiplication and division, and this is one of the places where if people use PEMDAS, they will say, this means I should do multiplication first. But I want to remind you, multiplication and division are the same thing. And the thing that we learn with fractions is that dividing by 2 is the same thing as multiplying by 1/2. The reciprocal of 2. So I can rewrite that equation, I can rewrite that expression as 6 times 1/2 times 3, very much in the same way that I could write this subtraction as addition by the opposite. Subtracting 2 is the same as adding -2. So, same thing, dividing by 2 is the same as multiplying by 1/2. And so now I can do this way, and when I see that, I can do either way first. So if I wanted to do 6 times 1/2 first, 6 times 1/2 is 3, and then I would multiply that by 3 to get 9. Or if I wanted to do 6 times 1/2 times 3, if I wanted to do 1/2 times 3 first, that'd be 3/2. Multiply that by 6, and that is still 9. Okay? So, again, recognizing that multiplication and division are very, very related, and that dividing by any number is the same as multiplying by its reciprocal, then that will actually help us fix this question. And the conventional wisdom portrayed by a lot of books, and also reinforcing Khan Academy, is that if you have a string of multiplication and division, you just read left to right. So this would be the way to do it, and not that. But I want to reinforce the notion that division by any number is the same as multiplying by that number's reciprocal, and multiplication is commutative. So we can rearrange the order of that. And so, I mean, we could have also, since multiplication is commutative, we could have also done 6 times 3 first, and then take that times 1/2. 6 times 3 is 18, and 1/2 of 18 is 9. Okay. The next and last little piece of caution on this is, again, to think about this. The order of operations, again, is a convention of notation, and it is not a specific rule that you must always follow. Okay, and what I mean by this is we have learned some flexibility of calculation in this class, and I want you to not lose that for following the rules of order of operations. And this is kind of one of the reasons why I don't like to emphasize order of operations at the very beginning of the semester. And you'll notice that order of operations is way back in the review sections. But I kind of like to ignore it for a little bit just because we're developing this flexibility of calculation. And I don't want to destroy that with rules. And I really like a quote that I heard in one video where I heard somebody say, don't let notation get in the way of your understanding. And I kind of think that that's the case here too. So this is one place where, so as an example, we have 4 times the quantity 10 plus 2. And the order of operations says that 10 plus 2 gets done first. And that is 12. And so this is 4. 4 times 12, which is 48. Okay? And you can see a picture here that basically has like it's a 4 by 12 rectangle. And if you want to count up how many little squares there are in here, there's definitely 48 squares. Okay? And it's 4 rows where each row has 12 squares in it. But if you think back about some of the earlier calculations that we did, like especially a lot of mental calculations, it might actually be helpful to do this as a split up piece rather than as a put together calculation. So what I mean by that is you could do this calculation of how many squares there are in here by splitting it up. 4 times 10, there's 40 in this rectangle, and then 4 times 2, there's 8 in that rectangle, and so we have 48 altogether. And we certainly did talk about this at other stages of splitting up these calculations in order to help you remember your multiplication table or whatever. And this is basically using the distributive property. So the distributive property says that in addition to adding the 10 plus 2 first and then multiplying by 4, you could also say this is 4 times 10 plus 4 times 2, which is, it's called the distributive property because you're distributing that multiplication by 4 across the sum. And the picture, again, shows why it makes sense that you should be able to distribute that multiplication across a sum. And so this is 40 plus 8, which is 48. So again, there is this order of operations, which is a convention of our notation, but it is not an absolute rule that says you always have to do this calculation first. It basically just says if I have a mix of notations, or a mix of operations without grouping symbols to specify what things get done first, then my practice is going to be to do exponents before multiplication and division, and to do multiplication and division before addition and subtraction. All right, I hope this helps, and I'll see you later.